acceleration around first base on your way to second. So you hit the ball and you're breaking, we're going to put double. And it's important you get on second base, right? And it eliminates double play possibility with force. Okay, so the solid path here is the wide angle. And then, so the path with the diamonds is the round out method. Where is the narrow end? Yeah, the narrow end is like this. You don't have this big. But then you got to make a, a short. You have to turn to an angle here, not much distance, whereas here you have much more distance. So you can go much faster turn through this angle. And then there's a round out method like that. I've never seen anyone run the bases like that. But anyways, we went through it, and you want the lower ranking, right? It's the wide angle that wins. Although the narrow angle yeah, the narrow angle wins over the round. The round out is the worst.
Is the round out?
That's the method here. It's kind of a dumb method. Maybe they just threw that in for a method.
For the
It's too many sharp ends. You're going as fast as you can. If you have to do a short angle, if you have to turn within a short distance, then you really have to slow down. So now you know how to run the bases. You can make millions of dollars over a year. Every time you pitch, you can make $500,000. Getting close to that. It's too bad, right? Okay, so any questions on Friedman's test? That's what we were going to talk about. Nothing new today. I'd like to go over Friedman's and Jean-Pierre Turf's and look at those problems. We went through a lot of problems with Friedman's. Again, you have the observations. You're still interested in like K treatments or K levels. Both of these problems are still one-way layouts. But in the Friedman setup, you take your data in blocks. So you have dependency within a block. And you have to account for that in your model. The model would probably throw a random effect. Have Yij, and then you could have a treatment effect. So this would be what? I guess I was blocked, so it's what I think. So this would be beta J. And then you throw in this would be my problem. And this is random. So when you're looking at a randomized block design, you shouldn't be testing for blocks at all. You can do a two-way ANOVA machine and get the right answer for treatments, but you shouldn't look at the thing for blocks. It's just a random effect, and there's no interest. It is the one-way setup, really. The interest in testing these betas, I have an effect here. I'll still just say beta. Beta 2, beta 2, beta. So this is still the hypothesis. Okay. But Friedman's is nice, you just rank within a block, it's an easy one to do by hand. And then we just compare, you still do the same thing as you do in the Kruskal Wallace at the end of the day. That's just what here's the data. Without course, in fact, we have the rankings. With this baseball one we talked about. So there's 22 different baseball players. Each baseball player is blocked. Okay. They'll be different, right? It's like a paired design. Again, if I didn't have this here, it would be just a paired design. I got a third level, so I have to take that into account. But then you just rank within a block. Right? So this was the lowest. This one is in the middle. And this one's the lowest. Let's see that. Like that. So in this case, we did this one in class, and this comes out to 11.1, and you reject if it's greater than or equal to chi squared with k minus 1 degrees of freedom, which is 2 in this case, right? K is 3. And we worked that out, we rejected it. I think the p-value, yeah, here it is, p-value is 0. Okay. Now, there are rank-based approaches to this model, and it's something I've been working on, actually, I guess recently. We had a paper published in 2009. Okay, but I'm not going to do that. And the last thing we were looking at was the John Pierre test, and it's a test for ordered alternatives. It's the same setup as a one-way. It doesn't have a, you can do it with a block, okay? So just keep J as 1 through K, okay? So this would be the response. Level J, or treatment. Okay, and then this is just a one-way model, right? A model Yij is J, no block. Okay, and let's write this as mu J. Here. So Yij is some mean or medium, it won't matter, we're looking at effects really, okay, plus error, and the only difference is we order the alternatives under H sub A. H naught stays the same, the means are all the same. So down at this point, it's what? Kruskal Wallace, right? Say we have K levels. But then as soon as I put this hypothesis down, it's no longer Kruskal Wallace. Now we have ordered alternatives. You need one, at least one strict. Then John Pierre's test is very simple. He just looks at the Mann-Whitney's, okay, where I guess we use S and T, where S is less than or equal to T. So it's the sum over S less than T. U sub ST. U sub ST. T is supposed to be the bigger thing right under the alternative, so we're counting up the number of observations and sample T. Notation is very bad. Actually, it would be different today. Let me use the Y's I have there. So this would be y I t, right? Greater than y I prime. I'll put a prime on that. But that's just the Mann-Whitney for looking at columns S and column T, and S is always less than T. Okay. And if the alternative is true, you should see in this ordering these things big, right? So it's a very intuitive test. You're just going to reject if J is too large. There's your percent. Okay. And then again, null expectation of J would just be this, right? This is the Mann-Whitney version, right? It's winning in the matches. And you can show because it will end sum up to the total sample size and get this other formula, but that's the intuitive, right? That's what it is. And it comes out to something that's sort of non. And the variance is so okay. And I suggested. Yeah. Vital lung capacities for 3 groups of 6 children were obtained. And one had 1/3 session, 2 had several, and 3 had none. Of course, I got. I should have rearranged today. So we want this. So 2 should be. Oh no, I did arrange it. So I prearranged the. And you could just go through and count up the number of times 1 meets 2, really. And then sort it. I don't know what this. Did we work this on? Didn't we work on? We had it on the. And then I would just pre-sort this thing. Okay, then group 1 the same way. Okay, so now they're pretty short, they'll be easy to do. We need U2, 1, right? This number times 1 beats 2. And you can just go through them, 57, 1, 2, 3, 4, 5, 6. N1 is 6. Now for the formula, I would change these back to 1, 2, and 3. I don't think this is important matter. And then 3 is 7, right? So the n in this case would be 2. And then I would just, you can just go through and count them. 57 beats what? 3, right? And then 66 beats 4. 67 beats 4. 71 beats this 4. And 79 beats 5. And 85 beats 5. So we have that one. Then we need U2, 3. So we need to add that up. It's got 12 and 22, 25. Okay, and then it's these two, right? So 80 beats 5, 81 beats 5, 85 beats 5, 90 beats 5, 93 beats 5, 101 beats 6. So this would be what? It's 25, 31, 37. And then finally we need these two. So 80 beats 5, right? 31 beats 5, 85. There's a tie, so it beats 5.5. And 90 beats all 6. So this adds up to 18, 28, right? 33. Any questions on that? That's the ranking for Jean-Pierre. Now J is just the sum of those. So the J in this case would be 95.5. Right? So this would be our J, and then we just have to stand. So we need the mean. And that's it. That's what we talked about. So 10 squared, 19 squared. And then it's what, 6 squared plus 6 squared plus 7 squared. So I'm just going to use my thing like that. Okay, so it's 19 squared. 72. If I did this right, it is 16. So we're way above that. And then we just need the variance, which is that's a bit messy. And then part 1, part 2. part one is just that, right? So that's what 19 squared times 38. So pretty much. Just do combine them. I've got to sum those, which was 2 times 36. 36 times 15. So that's 12,888. And then I got to divide that by 72. So my B is, seems high, but B is 179 if I did it right. So then Z would be what? 95.5 minus 60 divided by the square root of 179. So I think we can calculate this. So let's go 35.5. So it's 2 points. And then my p-value would be 1 minus p norm, right? So it's 0.00. Any questions on that? So I just use it. Certainly, one of the problem with the Jonquière is it assumes that order. So you can definitely think of situations where the order is not attained, right? Theoretically, like mu1, maybe you have 3 means, but mu1 is definitely less than 3, but mu2 is barely, say mu1, be less than. But if the first big positive difference, I would say, is much larger than a smaller difference, you probably going to reject it, not come to the wrong conclusion. I mean, you can. Okay? That, some people really worry about that. But you know, when you assume a model, you should have a good reason to do it. If you're flaky on the ordering, then you're probably best off doing a across the wall stance. See, the person doing the analysis is picks the alternative. But this is a generalization of the one-sided, two-sided argument, right? Now, if you just have 2 treatments, then the Jonquière hypotheses, the ordered alternative would be a one-sided test, right? And the Kruskal-Wallis would be the two-sided test. You just have two means. K is 2. That's your Kruskal-Wallis, right? Wilcox. That's your Kruskal-Wallis test. Two-sided, it's a Mann-Whitney, Wilcoxon, two-sided test. Which is equal to the Kruskal-Wallis, right? You take the z formulation of this and square it, you get the chi-squared Kruskal. Now, the inequality would be less than or equal to with one strict, but there's only one inequality, so it would be this. So this will be a Mann-Whitney one-sided. Which actually in this case would be equal to, say, toast. That should be a toast. It was too long. And we talked about this before, like with the cigarette industry, on secondhand smoke. Of course, this side is more powerful. Right? You don't have to, you only have to exceed, for 5% here, using Z, you only have to exceed this to ring the bell, and over here, you just have to work much harder. It has to exceed this, and that's exactly. So we've seen this difference before. Sort of a neat test. I've worked on some alternatives to this. I worked with Brad Heidemann in the psych department. Instead of doing that, Jean-Pierre does experiments. And they're almost equivalent. About 10 years ago, when we were working on this. So another way to do it is there's experiment. What you do, if you go back to this exercise we just did. Take the data and you stack it, so we get 35 through 38, right down to 34. And we have the next one, which is 38 again, 37. And then 40, down to 48. And then that's your Y instrument, and your X is just, these are all the ones, these are all the twos, and these are the all. And your test statistic is just Rx. You could use that T version, or we talked about this. I think you rejected T as T. I talked to Brad Heidemann about this. I thought, well, that's sort of neat. But then that was in the literature next to it. Oddly enough, the one person who worked on it was my advisor. He worked with someone else on it. So I got his paper. Tom Evansburg. This is quick. The one nice thing of going about this, you sort of have a correlation coefficient here, and it's measuring the strength of the relationship. It's something you don't have in a Jean-Pierre. Well, you could say I have the p-value. In a sense, that's measuring the relationship of strength. But this is RS is a correlation coefficient many people understand, and if you're close to 1, then that's really strong. In fact, interpretation is often on the square rate, variation. The amount of variation explains. So you can do that with, you could square this RS and talk about it that way. And I wrote a paper with Matt Heidemann and Josh and Randall on this. What we did was a bootstrap the standard. That was many years ago. Everything is many years ago. Questions? Questions? That's the end of the course. I don't have anything else to BS about. Oh, I know the one thing I wanted to mention. If you go back to the percentages, we haven't had one homework, so I hope you don't mind. I would like to do the percentages like this. Final is 35%. I keep that, okay? That's low. I wouldn't change that. And then I have 65% to make up. I'm thinking of the project as 15, and then 50 on the best value business.
So that quiz 2 take home was a.
I'll count that as a quiz.
Okay.
That's true. I did have those wrong. I don't want to do that. I'd rather do it this way.
So we just have one more and
Yeah, that's all we have. I'll count the take-home quizzes at one. The take-home quizzes. I forget why it was snows.
Yeah.
It's probably going to snow again. Probably snow the day you take the final. Any questions on the material then? It'll be a multiple choice test and it'll be comprehensive. Make out a one-page cheat sheet, front and back, 8.5 by 11. Okay, you can't use your computer, you can use a calculator only. And bring those tables.
25 questions. How many questions?
I don't know.
Okay.
It's what, it's 12:30 on Tuesday. This room. Okay? Any questions? I don't do a review, I used to do a review. And then one time I did a review and I turned around and I didn't want to sleep. I felt sleepy too. So. But I'll be glad to ask any questions if you have any. If you have questions, you can always email me. I'll probably be in tomorrow morning or something. If you want to see me, just email me. And we'll set that time.
Well, problem number 53. Wanna go over it? You know what you're doing. What?